Okay, so remember this odds against stuff? Today we didn't have any of this, right? I think it was all probability. Odds for, odds against. Probability, you look at the total. Odds for and against, you don't. How many cards in a standard deck? Anybody play cards over the weekend? Okay, 52 cards. How many of them are black? Half the deck. Now, how many of them are even? Or do we need to find all the even cards? This is black or even. So if it's black, I don't care about the even black cards, do I? Those are already included. So I can get all complicated and use the formula and go probability, no, actually not probability. I want the black cards and I want the even cards, and then I want to subtract the even black cards. I think most of you would use some common sense and go, well, I want this or that. I want to collect these together, the black and the evens. So I'm not going to double count the even black cards. Okay, so that's the black cards. So what other even cards are there that aren't already included in black? Well, the red even cards, right? Which are, is ace even? That's taken as a 1, right? And in blackjack it's taken as an 11, but it's not even in either case. Okay, so I got 2, there's a 4, there's a 6, there's an 8, there's a 10, and then what? What's a jack? Would you call that even or odd? It's even. It's taken as a 10, isn't it? Like, it doesn't mean 11. Okay, Sean? Yeah, it's a jack, but it's 10. Its value is 10. 10. Queen, 10. In games that they take values of them. Okay? All right, argue that it's not a great question, but is there just one suit of reds? No. There's 2. There's hearts and there's diamonds. Okay, so there's those, there's those, there's those. You guys played, nobody's ever played blackjack, 21? Okay, well 21 is if you get any of those and an ace. That totals 21. These are valued as 10, an ace is valued as 1 or 11. Okay, a blackjack is a face card and an ace. And you'd probably win, okay, because it's, you know, harder to get that than any other 2-card hand. But if you got a 2 and a 4, you would keep drawing until you got something close to 21. Now the odds say you should stop at 17, because if you go over 21, you bust and the other person wins. No, you don't. You have to get as high a hand as possible, right? Now you're not allowed to, but doesn't anybody even do the scratch and wins? You get those for Christmas or something? You're minor, so you're not allowed to play, but you know, you're playing for your parents, right? No, you really, eh? Oh. Okay, times change. So I got 26 here, and I have 1, 2, 3, 4, 5, 6, 7, 8 there, but I also have 8 there. So now probability would say 26 plus 8 divided by 52. But we're not asking probability. We're asking odds against. Well, how many is that? That's 32, right? No, it's 42. Out of 52. Pretty good likelihood you're going to get a black or an even card. There's not many that aren't there. Okay, but I'm not asked that. There's 42 that are, if I want to go odds 4, it's going to be probability of that. Well, I keep using the word probability. The number of times that will happen versus the number of times it won't. Well, how many times won't it happen? What's the probability of not getting that? 10 out of 52. But I'm not asked probability. Okay? That's got to add to the total when you do this odds 4, odds against. Okay? So 42 and 10, well, that's 52. That's your total choices. Did I answer the question? I did odds 4. Odds against, all you do is flip them around. 10 to 42. Or you can write it like that. You can write it as a decimal, 10 divided by 42. They'll probably reduce this too, right? So 521, if you're looking at the answers, it all means the same thing, okay? That makes the most sense, odds against. Okay, so it's not probability. There's no 52 here, but these add to the total. All right, any questions on that? Okay, we've done it, but you know. Okay, one more. Probability of a grade 12 math student passing the course. Now I didn't look up any data here. I'm just pulling some numbers out of the hat. Okay, 88% sounds pretty good. So that's not their mark, that's a probability of any Math 12 student taken at random from, say, I don't know, across BC. The likelihood of them passing is 88 times out of 100. The probability of a Math 12 student completing most of the assignments is 73%. %, of the students who complete most of their assignments pass the course. Determine the probability that someone doesn't do most of the assignment and doesn't pass. Too many words. I almost don't have enough room for my little Venn diagram. What, you can't see, Yashin? Oh yeah, I know. I don't like too many words in math, but that's the minimum required, I think. So we did this yesterday. Okay, so Math 12 student passing, let me use my highlighter, passing the course 88. What else do we got? Completing most of the assignments, 73%. The next little bit's a little different. But let me start there. Okay, I'm going to make this a little bit bigger. So, passing, that's 88. Completing most of the assignments, that's 73. You've got to assume that's 100% there. Okay? Otherwise, I guess what percent means, right? It's out of 100. If it says 88%, that means out of 100, irregardless of how many people this is.
Can you stop saying irregardless? It's not a word. Regardless is a word. You just bothered me so much by that.
Really?
Yes.
I will look it up. Are you sure?
Yes, I am.
Okay. All right. I am going to look that up. But I am a math teacher, not an English teacher. Okay. Irregardless, 95% of the students who complete most of their assignments pass the course. Where does that go? Read it carefully. 95% of the students who complete most of their assignments. How many students complete most of their assignments? I want 95% of 73%. Okay? That's what that says. They pass the course. So, that is the intersection, but I don't put 95 here. You see the wording? It says 95% of the students who complete most of their assignments pass the course. Okay? That's the little difference here. So, how do I do that? Well, let me write it. What is 95% of 73%? Okay, I want to make that a decimal. Of means times, so that might be the best way to do that. 0.95 times 73 is 69.35%. That's still percent. That's the number I want to put in there. Okay, so that is an intersection. Most of you caught on to that, okay, but yeah, that's a little different. Who complete their assignment also pass the course, right? That's an intersection. That's both things. Okay, all right with that? Okay, what do I want to know? Well, you may just want to fill in this diagram and answer the question later. Okay, it might ask you 2 or 3 things, or you might just want to, as quickly as possible, get to the answer. Determine the probability someone doesn't do most of the assignment, so I'm not in that box, and doesn't pass, so I'm not in that box or circle. Okay, that's what I want. I want that thing right there. Okay, so I mean, how I would do that is I would go, what? If 69.35% are in here, then you take the difference, okay? $18.65. That must be there. Okay? These two got to add up to 73. Which is just 3.65%. And then, well, this all has to add up to 100. Okay, so that's the way I kind of would do it. But there's other ways, like I showed you yesterday. Okay? So So you can go 100 minus 18.65 minus 69.35 minus 3.65 and be left with that one. Okay, then double check. Does it all work? Does it all add up? Okay. These two guys got to add up to that. And these two guys got to add up to that. And I think they do. And then double check again. Do all that add up to 100%? Okay, it's all got to work. Okay, so that should be enough. 6 to 8, 12 to 14, 16, and 17.